Alrighty, welcome back to another set of online lectures for Math 132. Today we're going to be working on Chapter 4, Section 1. And from the earlier lecture video examples, you would have seen that this section is about finding areas underneath curves by using Riemann approximation. This first example, example 1.9, we're going to do that process using a table of values. So in this first example, this table of values is used to show the velocity given of a bird flying through the air with its speed increasing during the first 3 seconds of its flight. And the speed is given in half-second intervals. There we go, our half-second intervals. And we want to find the lower and the upper estimates for the bird traveling during these 3 seconds. So let's graph the situation really quick. Alrighty, so there's a graph of the values given to us in a table. And the way that we're going to find the lower estimate is by doing a left-hand sum here. And that's because the function is always increasing. So in any given interval, the left-hand endpoint is going to be the lower value, and that's going to make our lower sum. So if we take a look at this first interval, the interval from 0 to 0.5, we can either have 0 be the height that we use for a rectangle, or we can have 3 be the height that we use at the rectangle. Those are the y values that we see here for the first interval, and since we're trying to find the lower sum, we're going to choose 0 for our height right there. And so for that first rectangle, we actually get just a horizontal line here on the axis with area 0. Let's draw in the rest of our rectangles. You can see here that if for every interval we choose the left-hand endpoint of that interval and we let that left-hand endpoint determine our height, that's going to give us a lower estimate for the area underneath our graph, which is going to be the total distance traveled in this particular example. Alrighty, so now we've sketched that area, let's go ahead and do the calculation to find the area. So we need to find our lower estimate, which in this case is going to be a left-hand sum. We're going to do that. Notice that we have 6 rectangles here. That first rectangle is of area 0, but then we have 5 more rectangles here, and each of them will have some area. So for each of these rectangles, notice that the width of the rectangle is 0.05. So if we're doing base times height, our base is going to be 0.05. So we should get 6 of those. Alright, there are the areas of our 6 different rectangles. And for the first rectangle, our height is 0. For the second rectangle, the height is 3. And that's because the y value of that point is 3. And then for the third rectangle, our y value is 4. And for the fourth rectangle, the y value is 5. For the fifth rectangle, the y value is 5.5. And for the sixth rectangle, the y value is 6. You can also see here that I'm making a decision between the left and the right endpoint for each one of our 6 rectangles, and so I can look at the table to determine these values as well. So let's do some quick simplification. We have 0 plus 1.5 plus 2 plus 2.5 plus 2.75 plus 3. And so our lower estimate is 11.75 feet. And that is because we have feet per second multiplied by seconds. So we're doing feet per second times seconds. And so our total should be given in feet. And that's because that's what the area of a velocity graph gives us, is the change in our position, which is given in feet. All right, I'll give you just a few seconds to write that down, and then we're going to change and do the upper estimate. The upper estimate is going to be a right-hand sum. Let's sketch those graphs really quickly. I'm going to get rid of the left-hand sum graphs right here. All right, now let's draw in our right-hand sum rectangles. So we want to go up to what would be the right-hand endpoint of each particular interval. So we're going to be reversing the process here. We're using a right-hand sum instead of a left-hand sum, we still have just 6 rectangles, even though our first rectangle, when we did the left-hand sum, was a 0 area rectangle. Now we have 6 rectangles that all have some area. But again, the distance between the two interval endpoints is 0.5, so we're going to get 6 of those. But now we're going to choose the right-hand endpoint of each particular interval. So for this first interval, between the 0 and the 3, we're going to choose the 3 because that's the right-hand endpoint. So we're going to do 3, 4, 5, 5.5, 6, and 8 because those are the right-hand endpoints of each of the subintervals. Now let's do a little bit of simplification. We get 1.5 plus 2 plus 2.5 plus 2.75 plus 3 plus 4, and that is equal to 15.75 feet. And so our lower sum is 11.75 feet, and our upper sum is 15.75 feet. And those are the lower and upper estimates for this particular problem. So I'll give you a few seconds to write that down, and then we'll go on to the next example. Alrighty, let's take a look at the next example here. So very similar problem. This is out of the web work. This is web work 4.1, number 4. We have speedometer readings here at 12-second intervals, and we want to estimate the distance traveled by using the velocities at the beginning of the intervals for part A, and then we want to use them at the end of the intervals for part B. Another way to think about that is that we want to be doing the left-hand sum for part A and the right-hand sum for part B. I want to give you a second to take a look at this one on your own because I think that you can do this one. It's just like the last example. To help you out a little bit, I've given you the answers here. The answer to part A is 1,044 feet, and the answer to part B is 1,284 feet. Now take a second and pause the video and try to work out A and B on your own. Alright, let's take a look at a solution for these. For part A, you're finding the left-hand sum, and you would have done that by taking the interval, in this case the interval width is 12, or multiplying that by the left-hand endpoints for each one of the intervals. So 12 times 5, and 12 times 10, and 12 times 20, and 12 times 22, and 12, so I'm going to start a plus sign there, plus 12 times 30, and if you notice, we can undistribute a 12 here, and we end up with just our sequence of our endpoints. So we get 5 plus 10 plus 20 plus 22 plus 30. And that is going to be a little bit simpler way to calculate it, so we can do the division at the end. And for part B here, all we're going to do is we're going to switch this first interval. We're going to choose the 10 here, because we're going to choose the right-hand endpoint rather than the left-hand endpoint. And so our right-hand endpoints are going to be 10 and 20 and 22 and 30 and 25. Again, we can undistribute the 12. Write the sequence of our endpoints here, our right 5 endpoints. And then when we multiply and add those all together, we get 1,284 feet. Take a second to pause if you missed any of that, and we'll move on to the next example shortly. Alright, let's take a look at the next example. For this example now, we are going to be using a formula for our equation to determine the heights of our rectangles at our endpoints. We're doing it on the interval from 0 to 4 using 4 rectangles. This is going to be a little bit tricky because we're going to have some fractions to deal with. So first, let's use a number line to organize a little bit what our intervals are going to look like. We're going from 1 to 4, and then we're subdividing the interval into 4 different rectangles. And so we're covering a distance here of 3, which is 4 minus 1, and then we need to make that into 4 intervals by dividing by 4. So each of our interval widths should be 3/4. So we're going to move over 3/4, which is going to land us on 1.75. And then we're going to move over 3/4 again, which is going to land us on 2.5. And then when we move over 3/4 again, that's going to land us on 3.25. And then finally, we're going to land on 4 right there. Now that we have our endpoints, we can go back and we can see that the problem is asking us to find the right-hand sum. So what we're going to do there is we're going to go ahead and multiply by the width at each interval, which is 0.75, and then we're going to multiply by the function value evaluated at the particular endpoint. So for this first endpoint, our right-hand sum is going to use f of 1.75 because that would be the y value above 1.75, which is our first endpoint right there. Let's go and do that for the rest of these intervals. So we're going to get 0.75 times the function evaluated at 2.5 plus 0.75 times the function evaluated at 3.25 plus 0.75 times the function evaluated at 4. Now, if we do some simplification, we get 0.75 times 0.75, because we're going to do 0.75 minus 1 divided by the square root of 1.75 plus 0.75 times 1.5 divided by the square root of 2.5 plus 0.75 times 2.25 divided by the square root of 3.25 plus 0.75 times 3 divided by the square root of 4. And this is our final answer. We don't actually need to multiply out any further there because we're just going to get crazy decimals when we have these square roots of decimal numbers in our fractions. So that works for a final answer on a quiz or an exam. On web work, you could plug that all into a calculator just to make it easier to type in the decimal answer. But this particular function is a little bit nasty for that. Let's go ahead and move on to the next example, since all we're doing here is we're plugging in the endpoint values into our original function to find our height. Alrighty, let's decode this problem a little bit. So we have this function, so this is going to be similar to the last example. We're going to have a function determining our height of our rectangles in each interval. And then we have our interval given as being 0 to 6. And now we're trying to find the area using left-hand endpoints, and our delta x is equal to 1. That is the width of our subinterval, or the width of our rectangles. So that means if we have our length of our interval divided by delta x, we have 6 minus 0 over 1. That means that we have 6, and that is the total number of rectangles that we're dealing with. So we're dealing with 6 rectangles in this particular example, part A. Another way to look at that is that our interval is going from 0 to 6, and if we're having a distance of 1 for each subinterval, if each one of these gaps is 1, that means that we're going to have 6 subintervals right there. And that's going to land our endpoints at the integers 1, 2, 3, 4, 5, and 6. Alright, let's go ahead and find the left-hand sum like this first example asks us for. So we're going to do 1 times f of 0 plus 1 times f of 1 plus 1 times f of 2 plus 1 times f of 3 plus 1 times f of 4 plus 1 times f of 5 plus 1 times f of 6. And I've made an intentional error here. What did I just do wrong? Take 1 second. What's wrong in this particular equation? Well, what's wrong is I included 1 times f of 6 here, and that doesn't make sense because my intervals here are from 0 to 1 and 1 to 2 and 2 to 3 and 3 to 4 and 4 to 5 and 5 to 6. And so taking a look at this 5 to 6 interval, we're choosing f of 5 as the height of our rectangle because we're taking the left-hand sum. That means that we have 1, 2, 3, 4, 5, 6 rectangles. We don't need f of 6 here. That's the right-hand endpoint of that last interval. All right, let's do some of the simplification. F of 0 is 0, and f of 4 is 0 as well, so those ones are 0. F of 1 is 9. F of 2 is 2 times 4, so that's 8. F of 3 is 3. F of 5 is 5. And so we have that our sum here is 9 plus 8 plus 3 plus 5. That's 16 plus 9. That is 25 there. And we don't have any units that we're dealing with. So our answer is just 25. That is an area unit, but we don't have any units given to us. So we can think of this as being unit squared or something like that. But we can just say that the estimated area under the curve here is just 25. All right, now let's take a look at part B here. Part B is saying that we're finding a right-hand sum. And now it's telling us that n is 3. That means that we have 3 rectangles. So if we're going from 0 to 6, and we have 3 rectangles, that must mean that our other endpoints are at 2 and at 4. And again, if we do b minus a, in this case divided by n, that's going to give us our delta x. And 6 minus 0 over 3 is equal to 2. So 2 is our delta x. And that's exactly what we see right here, that we have a distance of 2 in between each of our endpoints. All right, let's go ahead and find our right-hand sum. So the distance between them is 2. And then we're going to be doing f of 2 plus 2 times f of 4 plus 2 times f of 6. And the trickiest thing probably here to notice is that I skipped using the endpoint at 0 because we're taking the right-hand sum, and so our first rectangle is going to have f of 2 as its right-hand endpoint. Now let's go ahead and calculate these numbers. So f of 2 there, that is 8, and f of 4 is 0, and f of 6 is 6 times 4, so that's 24, and then 8 plus 24 is 32. Well, that's our final answer for that problem, and I'll give you just a second to go ahead and take a look at those two examples. Alrighty, here is what left-hand endpoints look like. And you can see that the left-hand endpoint approximation yields 25, which is the answer that we found. And then if we want to take a look at the right-hand endpoint approximation, there's the right-hand endpoint approximation. Remember, we did this with only 3 rectangles. So there's those 3 rectangles. Remember that middle rectangle was height 0. And our answer should be 64 there. Go back to our work. We did get 25. And would you look at that? We made an error here. We accidentally dropped our 2's from our calculation. So we should have multiplied this whole thing by 2 at each step. And when we do that, we get a 64 there for our final answer. And that's a really common error, because a lot of times we'll see that we get a width of 1, and then the answer is just a sequence of numbers. But when our width is something that's not 1, we have to make sure that we multiply each rectangle by that width. All right, let's take a look at the last couple of examples here. So this first example that we're taking a look at, example 113, is WebWork 4.1 problem number 3. So this is similar to the last examples where we are going to take a function and we're going to have an interval from 0 to 12, and then we're going to try to do an overestimate and an underestimate. Now note, this is phrased differently than the last problem, in which we were trying to find a lower estimate, or a left-hand sum and a right-hand sum, Now we're trying to find an overestimate and an underestimate, which is a mixture of left-hand sums and right-hand sums. So in order to do this problem, we're going to start by constructing a table of values. So for this table of values, we want to choose our x values to start at 0 and end at 12, and then we're going to take a look at the number of rectangles that we need to determine how far these values should be apart. So if we're trying to do a distance of 12 minus 0 divided by 4, so this is b minus a divided by delta x. Divided by n, because we have 4 rectangles. What we get here is we get that 3 is equal to our delta x. So each of our x values should be 3 apart, so we're going to need x values at 3, at 6, at 9, and at 12. And then what we want to do is we want to plug in each of these x values into our function up here, f of x. When we plug in 0, we get a 0. And when we plug in 12, we also get a 0 there. And I knew that because I know that we can factor our f of x. If we plug an x right there, we get 12 minus x. And I know that when I plug a 12 into 12 minus x, I get a 0. Let's go and calculate the rest of these. So if we evaluate this at 3, we're going to get 3 times 9, which is 27. If we evaluate this at 6, we get 6 times 6, which is 36. If we plug in a 9, we get 9 times 3, which is again 27. Now that we have this table of values, finding the overestimate and the underestimate is pretty straightforward. So to find the overestimate, let's first write down our 4 areas that we're going to be adding together. So we're going to have area 1 plus area 2 plus area 3 plus area 4, where area 1 is going to be between 0 and 3, area 2 is going to be between 3 and 6, area 3 is going to be between 6 and 9, and area 4 is going to be between 9 and 12. Now these areas are given by 3 times the height. That's going to overestimate the height in between 0 and 3. Well, 27 is bigger than 0, so I'm going to choose 27 as the overestimate of my height from 0 to 3. And then for the second area, from 3 to 6, we're going to choose 36 because 36 is bigger than 27, so 36 is going to be our overestimate. 36 is also going to be the overestimate at the 3 to 6 rectangle because 36 is again bigger than 27. And then we're going to choose 27 as our last height because that's going to be the overestimate between 27 and 0. When we add those all together, we get 378. Now let's take a look at this equation on a graph. So here's our equation, y equals 12x minus x squared. And then you can see when we're taking the upper estimate, we're going to use a right-hand sum for this first rectangle because we're using that right endpoint right there, and a right-hand sum for the second rectangle because we're using the right-hand endpoint right there. But then we're going to use the left-hand sum for the third rectangle because the left-hand endpoint is higher than the right-hand endpoint. That's why you see 36 show up twice in the calculation because we're using 36 for the right-hand endpoint here and 36 for the left-hand endpoint here. And then we're going to go back and we're going to use 27 for the left-hand endpoint for that last rectangle, which is what you see in our calculations. We have a 27, 36, 36, 27. All right, now let's go ahead and do the underestimate. So this is the overestimate. And when we do the underestimate, we're going to get 3 times 0 plus 3 times 27 plus 3 times 27 plus 3 times 0. So between 0 and 27, we choose the 0 for the first rectangle. And then between the 27 and the 30, we choose the 27 for the second rectangle. And then between the 36 and the 27, we choose the 27 for the third rectangle. And then between the 27 and the 0, we choose 0 for the fourth rectangle. And if we go ahead and crunch those numbers really quickly, we get 162 for our underestimate. And now let's take a look at that on that GeoGebra graph again. And so if we switch from the overestimate to the underestimate here, we have a 0 height and a 0 height on the left and on the right. And then we have our two height 27 rectangles, 27 left endpoint here, 27 right endpoint here, and that matches our work. So you can go and take a second and jot down those notes. And then let's go ahead and move on to the next problem. So this is a graphical example now, so it's going to be more of an estimate. What we need to do is we need to come up with an overestimate and an underestimate of the distance traveled by the particle on the interval from 0 to 6, given that this is the velocity graph for that particle. So let's go ahead and start with an overestimate. So I want to do delta t of 1 here, which means if I'm going from 0 to 6, I'm going to need 6 different rectangles. So I'm going to do 1 times something plus 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 1 times something. There's our 6 different rectangles. And now what we're going to do is we're going to try to find an overestimate here by taking a look at each one of the intervals and making sure that on that interval the graph of the function is completely contained by the rectangles that we're drawing on the top of the function to be the overestimate. So for this first rectangle, we're going to do a left-hand sum right there, and we're going to use this height here of about 7.5 for the height of our first rectangle. For our second rectangle, we're again using a left-hand sum and a height of about 4.5. For our third rectangle, we're again using a left-hand sum. Notice the function is decreasing on this interval from 0 to 3, so the left-hand sums are the overestimates. The height of this left-hand sum is about 3 right there. Then, as the function is increasing, we're going to use a right-hand sum to overestimate, which means that we need a height of 5.5 here for this fourth rectangle. And now this fifth rectangle right here is one of the most interesting rectangles because the maximum height is actually at the midpoint. That is another type of summation that we could do, is we could do midpoint summations. But in this summation, we're doing the overestimate. And so we need to take that height at the midpoint because that is the height that will ensure that the rectangle is fully enclosed, that the rectangle fully encloses that graph. And then finally, because we're decreasing, we're going to need to use the left-hand endpoint here for this last rectangle. And it looks like that left-hand endpoint right there is about 5.5. So now, if we go ahead and add those all together, we get 7.5 plus 4.5 plus 3 plus 5.5 plus 6 plus 5.5. So that means we're going to get 32 meters for this first estimate. So that tells us that the total distance is less than 32 meters because we can see here that we have these chunks of area that are overestimates of the actual area underneath the graph. Let's do the exact same thing for an underestimate here, except now we want our rectangles to be completely underneath the graph. You can draw this one right there, and this one right there, third one right there, fourth one right there, fifth one right there, and the sixth one right there. So again, it's going to be 1 times the height of each one of our rectangles. So we need to go ahead and make sure that we have 6 pieces of our sum. And for this first rectangle, it looks like our underestimate height is going to be something like 4.5. For the second rectangle, it looks like the underestimate height is going to be 3. And then a 2. Notice that we're going to use the 2 for both sides of this rectangle. For the 2 to 3 rectangle and for the 3 to 4 rectangle. This is the 2 to 3 rectangle right here. And this is the 3 to 4 rectangle right here. Looks like the maximum of this 4 to 5 rectangle is at 5.5, and then it looks like the minimum I mean, and then the minimum of this 5 to 6 rectangle is at 2. So we get 4.5 plus 3 plus 2 plus 2 plus 5.5 plus 2. When we add those all together, we get that 19 meters is our underestimate. So the total distance is at least 19 meters. Give you a second there to take a look at that work. Make sure you pause if you need some more time. Alrighty, and that's all the examples that we're going to do in the lecture video, because the last example is just another example of this exact same concept. So that's going to be left for practice if you want to do that for extra practice. But I recommend that you take a look at your web work at this point and get started on your web work, because you should know everything you know to calculate all the Riemann sums required on that web work. So with that, I'm going to wish you a good day, and we'll see you next time.